Have you ever noticed how the eastern coast of South America and the western coast of Africa fit together like puzzle pieces? That's not a coincidence, it's a clue to our planet's deep history. Hundreds of millions of years ago, there was no Atlantic Ocean. These continents were joined as part of a supercontinent called Pangaea. Imagine standing in Brazil and walking to Nigeria, no ocean in between, just a continuous world of shared plants, animals, and rocks. Our world map is just a snapshot in a long, slow-motion film of planetary change. So what tore these continents apart? The answer lies deep within the Earth. The crust isn't a solid shell, it's broken into tectonic plates floating on molten rock. These plates are always moving, shaping mountains, creating oceans, and splitting continents. Around 180 million years ago, a rift split Pangaea, magma pushed up, tearing the land apart, water filled the gap, and the Atlantic Ocean was born. The continents began their slow drift, a journey we can still see in matching fossils and rocks on both sides of the ocean. This is geology's power, slow, invisible, but world-changing. The story is written in the very shape of the continents. Our planet is a puzzle, always shifting, always changing. To understand why continents move, we have to look deep beneath our feet. The Earth's core is incredibly hot, creating convection currents in the mantle, like a giant pot of soup simmering. These currents drive the movement of tectonic plates, dragging continents along. Some plates move apart, others collide, and some slide past each other. This is plate tectonics. Down the middle of the Atlantic lies the Mid-Atlantic Ridge, a volcanic seam where plates are pulled apart. Magma rises, cools, and forms new oceanic crust, a process called seafloor spreading. This geological conveyor belt pushes South America and Africa apart, about as fast as your fingernails grow. You can't see it, but over millions of years, it adds up to thousands of kilometers. The Atlantic Ocean grows wider every day thanks to this relentless activity. The Mid-Atlantic Ridge is a silent construction site, building new Earth in the ocean's depths. Plate tectonics explains the world's mountains, earthquakes, and the very shape of our continents. The Earth is always in motion, even if we can't feel it. While the Atlantic grows, the Pacific side of South America tells a different story. The South American plate collides with the Nazca plate, which is denser and dives beneath it, a process called subduction. The Nazca plate plunges into the mantle, melting and fueling volcanic eruptions. This grinding collision creates immense pressure, causing earthquakes and building the Andes Mountains. The Andes are the crumpled edge of South America, shaped by this ongoing clash. Volcanoes dot the range, marking the fiery path of the subducting plate. The landscape, towering peaks, trembling ground, explosive mountains, is forged by this relentless process. Subduction recycles the Earth's crust, driving geological change. South America's dramatic west coast is a land shaped by fire and pressure. Africa's tectonic story is different. It's being pulled apart from within. Deep beneath East Africa, magma pushes upward, stretching and thinning the crust. This creates the East African Rift Valley, a massive crack running from Ethiopia to Mozambique. The land is slowly unzipping, marked by volcanoes, earthquakes, and deep lakes. Scientists believe the Somali plate is pulling away from the Nubian plate, a process that began 25 million years ago. Eventually, the rift could flood, creating a new sea and turning the Horn of Africa into an island. The East African Rift is a geological nursery showing us the birth of a new ocean basin. Africa's map is changing, reminding us that continents are always in motion. What does the future hold for our continents? By tracking plate movements, scientists can make bold predictions. The Atlantic keeps pushing the Americas west, and new rifts could one day split North and South America apart again. As continents move, they reroute ocean currents, reshaping climates and triggering bursts of evolution and extinction. Eventually, the continents may reunite into a new supercontinent, just as Pangaea once did. Theories like Pangaea Ultima and Amasia imagine different configurations, but the result is the same, a radically altered world. New mountain ranges, vast deserts, and shifting weather patterns would emerge. The cycle of supercontinents is a recurring theme in Earth's history. We're living in the middle of one great cycle, a brief moment between the breakup of the last supercontinent and the formation of the next. The world we know is just one chapter in an immense ongoing story. Our planet's surface is always evolving. Imagine if South America and Africa reunited, closing the Atlantic and forging a new mountain range, the Afro-American Mountains. Coastlines would buckle, and new peaks would rise where the continents joined. Countries once separated by oceans would share borders. Brazil next to Nigeria, Argentina beside Namibia. Trade, travel, and cultures would transform as new connections formed. Animals isolated for millions of years would meet, creating new ecosystems and evolutionary battles. Some species would thrive, others might vanish. The climate of this new supercontinent, perhaps called Africa-America, would change dramatically. The vast interior could become a desert, while coastal weather patterns would shift. The world's geography, climate, and life would be fundamentally changed by this reunion. The story of continents is one of endless transformation. It's easy to ignore these slow changes, but plate tectonics is our story. The story of the ground beneath our feet. It explains coastlines, cities, and the resources we depend on. Understanding these forces gives us perspective and connects us to deep time. Our planet isn't static, it's alive, always changing. Mountains and oceans are temporary, fleeting in geological time. Studying plate tectonics helps us prepare for earthquakes and volcanoes, and guides us to vital resources. Science isn't just about the past or future, it helps us live better now. Next time you look at a map, see the ghost of Pangaea, the birth of new oceans, and the outlines of continents yet to come. This is the grand story of our world, written in rock and time. We have the privilege to read it. Our brief lives are part of this immense cosmic journey. That's the wonder of being alive on this restless, beautiful planet.